Okay, so, remember those situations where you look at this thing and you say to yourself, self, that appears to be a product. But I know there's no product rules in antiderivatives, so there's got to be something else to do. Or you say to yourself, self, that looks like a chain rule. But we can't do chain rules with integrals. Now, those would all be true statements today. You'll also recall when I was talking about derivatives versus integrals, I mentioned that by now you should be able to take the derivative of just about any equation. Okay, some of them easier than others, but you can still use any of the techniques I've shown you to find the derivative about any function that I could present to you. However, not the same is true with integrals. A majority of the functions you will see are not antiderivatable. That's a word. Well, it is now. So today, I'm going to show you another technique that will allow you to do antiderivatives, but still only works for very specific cases. That'll make more sense as we start getting into it. Okay? We're going to do something called methods of substitution, commonly referred to as UDU. There's a very algorithmic approach to this, and I'm going to dive into this using that algorithm. Do you all know what an algorithm is? What is it? Step-by-step process to do it. Yeah. And once you get this step-by-step process, these problems are not that bad. Okay? So we're going to use UDU to solve more complicated definite integrals. In particular, this comes into play when we're dealing with problems that would typically be perceived as chain rule problems for integrals. You're going to learn to choose wisely. I'll explain that in a little bit. If you choose wisely, the problem is doable. If you don't choose wisely, it won't be doable. Does anybody know what movie that's from?
Indiana Jones?
Which one?
Yeah, which one?
Last Crusade?
Last Crusade, very good, Daniel. You win. You're free, you can leave. We'll also take a look at what happens when you don't choose wisely. What happened in the movie when he chose poorly?
Dies.
Yeah. His face, no, he didn't, no. That was in the first one.
was the one.
Yeah.
This is where he gets old and turns to dust, right? Yeah. That won't happen to you. Lost Ark is where where the Nazis' face got melted. In the last one, they turned to dust and just fell apart. And today, try to go out of your way to thank somebody who did something for you. Don't just look across the person and sitting across from you now and say thank you, unless they did something for you. Okay? Did they let you copy off of them during the last quiz? Did they loan you their car? Did they give you a piece of gum? Did they say you look pretty today? Daniel, did you tell Amy he looks pretty today?
No.
Okay.
Why not?
You could, and then he would thank you.
Yeah.
Just saying. You do you. Okay, so here we go. There's no fancy schmancy way to do this. It's just, we're just going to dive right into it, and you'll see through practice how this works. Up until today, if I had given you that problem, you would say, I can't do that. That's a chain rule. And you would be done. However, with UDU, we can solve it. So here's where you have to choose wisely. You're going to pick a value for u. And we'll talk a little bit about what your options are. So notice that is, well, let's back up. Let's suppose we're taking a derivative of that puppy, not an antiderivative. And we were doing a chain rule. And let's suppose this is the chain rule lesson. I would ask you, how many functions are involved in that problem? 2. So you would chain how many times? 1. Okay. We don't care about the chaining. We just care about the 2 different functions. What are they, Liam?
Ax plus 5 and square root.
Perfect. Okay. Being able to identify that will help you choose what u is going to be. You're going to choose one of those functions to be u. This one's pretty straightforward, so I'll tell you, let's try that again. Technology. You gotta love it. Now I think we're in business. Yep, there we go. We're gonna choose u to be 8x plus 5. I'm gonna choose the inside function. There's very seldomly a set way to approach this. However, it is fairly common for u to be the function inside, not the function on the outside. Okay?
Could you be the function on the outside?
You could, but it wouldn't end well for anybody involved.
Okay.
Over here, we're going to take the derivative. So the derivative of u is du. Okay. The derivative of 8x plus 5 is 8 dx. That's supposed to be an x. So we're doing implicit differentiation because I have u's and x's there. Okay, so far? So, step 1, choose u. Step 2, take the derivative of your u expression. Step 3, solve for dx. Step 4, now you do your substitutions. That's why this is called the method of substitutions. I'm going to come over to this little function over here, and I'm going to rewrite this function in terms of the u values. So I'm going to get rid of the 8x plus 5 because I know what 8x plus 5 is. It's just u times. And then I'm going to get rid of the dx. Well, what's the dx equal to? It's equal to this business over here, 1/8 du. Any problems so far? Okay. Now we solve. Now, by solving, I'm going to be smart and I'm going to move the 1/8 out in front. I'm going to write this as u to the 1/2 du. And I'll give you a couple of minutes to go ahead and finish that antiderivative. Go ahead. Taylor Swift big album. Yeah, it's like April 19th. The whole universe is going to cease to exist at that point. And everybody's going to shut down. Nobody's going to work. Everybody's going to be home listening. No, I don't blame you. You have to listen to the album 3 or 4 or 7 or 14 times in the day. Kush, what's the antiderivative of u to the 1/2?
U to the 1/2?
Yes, sir. U to the 1/2.
2/3 u 3/2.
U to the what, I'm sorry?
3/2.
And don't forget the 1/8 there out in front. Now, should the 2/3 u to the 3/2 plus c be inside parentheses? Technically, yes, but what's 1/8 times c? C. So we don't need it. Clean this up a little bit. Now, notice, I know what u is. This problem involves x. Your answer should involve x. So I would get 1/12 times 8x plus 5 raised to the 3/2 plus c. And I'm done. Any problems? Does that seem fairly easy? This is the audience participation part of the program.
Yes.
Okay, good. Well, no, that's not it. I got more for you. If I can get my clicker to work. Okay, let's move on. Now I feel the need to tell you, you don't have to do this as a UDU. If you're feeling all fancies in your panties, you could do Pascal's triangle to multiply 8x to the 5th minus 7, raise it to the 9th power, and then multiply everything by x to the 4th. But why would you do that? So now, we got a whole bunch of action going on here. I've got a chain rule and a product rule. So again, if I was asking you to take the derivative, you could do that. You would use the product rule, and within that product rule, you would also have a chain rule, but we're not doing a derivative here. So I have three options for my u. My u could be x to the fourth. My u could be 8x to the fifth minus 7, or my u could be 8x to the fifth minus 7 raised to the ninth power. Well, actually, there's 4. You could do the whole thing as a u, but that would be ridiculous. Okay. Abby, what would you like to try? And I'm hoping you pick incorrectly. So try to pick incorrectly.
Okay. The x to the fourth.
Great call. Don't write this down, just watch. Abby has no clue what she's doing, and she has chosen u being equal to x to the fourth, which, by the way, is wrong, which is why I don't want you to write it down, but I want to show you what it looks like when you choose poorly. So, step 1, pick a u. Step 2, take the derivative. du is equal to 4x cubed dx. Step 3, solve for dx. I forget what step I'm on. 4? Step 4, substitute. Okay, so this becomes, well, that becomes a u. I have nothing to sub in here, so I have to bring that down. And I know that dx is 1 over 4x cubed du. Now, the reason I know that that's wrong, and the reason that you will learn that it's wrong, is after I've done my substitution, I want to look for canceling. The problem is nothing cancels here. And as soon as you realize you have x's and u's, you screwed up. This is wrong. You knew that going into it. Again, x's and u's, it's bad. Abby chose poorly. So we come back here, we use the mighty eraser, and we ask Abby again, yo, what would you like for you now?
8x to the fifth minus 7 by itself.
By itself, not raised to the ninth power. Which one?
Raised to the ninth power. No.
You're just going to go with 8x to the fifth minus 7?
Sure.
You sure?
Yes.
Good. So far, so good, but I think you see where this is going. I can get rid of the 8x to the fifth minus 7 because that's what she chose to be u. I can't get rid of that. I have no substitution there, but I can get rid of the dx. Oh, and look at that. This is bad. This is good. Move the 1/40th out in front because it's not relevant. U to the 9th du. Nice simple problem. Which gives me 1/400th u to the 10th plus c, which is 1/400th times 8x to the 5th minus 7 to the 10th plus c. I would argue that that's a lot easier than multiplying it out. Questions? We're good? Can I move on? By the way, can you identify those two people in the GIF? I don't know who the person on the left is. I don't know who the woman is. I know who the guy on the right is. No? The guy on the right is Boy George. Lead singer of Culture Club.
How do we get to 1 over 400 from 1 over 400?
Raise the power to 9,
Yeah.
or from 9 to 10, multiply by the reciprocal. 1/10, 1/10 times 1/40th is 1/400th.
Oh, I see.
Any other questions? Hot diggity. You do this one on your own. Good luck. No crying. Quotient rule with a chain rule. Can't normally do that. Oh, wait, we've got u du. I'm getting after it. Choose a value for u. Go through the steps. Try something. Is this kind of personal things in my mouth? Would be funny. We tried to subtract one and get -4. So far, so good, I think. Let me see what's wrong. Duncan, what's u?
5x to the fourth plus 6x.
Beautiful. 5x to the 4th plus 6x. How'd that work out for y'all? Doesn't work. Amanda, what'd you choose for x? Or for you, I mean. How'd that work out for you? Huh? Okay. Notice. Well, not notice. Let me ask you a question. When you take the derivative, what happens to the degree of the function? It goes down, right? So if I'm whatever I choose for u, if I chose a 5th degree equation, when I take the derivative, it's going to cancel or going to reduce to a 4th degree equation. That's my not so subtle way of saying if you're not sure, pick the higher degree part of it. X to the 5th plus 3x squared plus 5 du is equal to 5x to the 4th plus 6x dx. dx is equal to 1 over 5x to the 4th plus 6x du. Did we choose wisely? Yes, because it cancels with the numerator there. As you get better at this, you can skip a step. So for instance, what I would do is I would realize that I'm going to put this in for dx up there, which means that guy is going to cancel with that guy. And I can go right to 1 over u cubed du. However, early on, if you would rather do all the substitution to see that, go right ahead. You're not going to get penalized for taking an extra step. Nathan, what's the antiderivative of u to the negative 3?
Negative 1/2 u to the negative 2. Plus c.
Thank you. Do your substitution here. Okay, early on I don't care about the negative exponent, it's fine. Later on we'll worry about cleaning them up. But for now I just want you to make sure you understand the process for u du. Here's the thing though. This equation is so contrived, it only works if the numerator is exactly 5x to the 4th plus 6x. That doesn't really open it up for a ton of different antiderivative problems. And that's why I said this is not as useful as a tool as initially it seems. It doesn't allow you to take the antiderivative of every function now moving forward. It's just very narrowed, but it does give you another tool to use for some of the problems. Okay. Are we doing so far? Beautiful.
So when you say don't worry about the negative exponent, like right now, does that mean for the quiz? Or the test, I mean? Should we worry about it on that?
I would worry about it at the test.
Okay.
Yeah. You got 4 days to get it all worked up and hyper. Ooh, now we want to do a definite integral. So we should get a numerical value. I'm going to show you how I like to do it. I'm also going to show you another way to do it that sometimes gets forced on you. That seems very silly. I'll explain as we get there. Okay. If I forget about the 4 and the 0, I can do an antiderivative using u du. This one should be pretty, you should notice already this is going to be pretty easy. And then sub back in and do my thing. Okay, so I'm going to do that first. Then I'll show you the more complicated method. Let's go purple. Okay, what's u? 2x plus 1, easy peasy. Du is equal to 2 dx, whoops, dx. So dx is equal to 1/2 du, which means this becomes the integral, with a 1/2 out in front, of the square root of u du. You'll notice I didn't include the 4 and the 0, and there's a reason for that. That 4 and 0 apply for the variables x. I'm no longer working in x, I'm working in u's. So I just drop them for a little while. I'll come back to them in a minute. Okay. Then I go and solve the problem. 1/2 square root of u to the 1/2 du, which gives me 1/2 times 2 thirds u to the 3/2. And not a plus c, because again, it's a definite integral, but I also haven't brought the numbers back yet. Now I do substitution. 1/3 times 2x plus 1 raised to 3/2 power. Now I'm going to evaluate from 4 to 0. Let's see. It says 9. Square root of 9 is 3. 3 to the 3rd power is 27. So 1/3 times 27 minus, put in a 0 there, I get 0 is 0 and 1, and it's 1 to the right says 1/3. So that's just going to be 1, which gives me 26 over 3, which does not divide nicely, so I get 26 over 3. I think I did that correctly, didn't I? Confirm that. We're good? Okay, beautiful. Let me give you a second to get caught up there. That's the way that I prefer to do it. And you would be good moving forward 90% of the time. But every once in a while, the College Board sneaks something in on you. Okay? And I'll show you what that is in a second. Once everybody's caught up. So remember, we should get 26 thirds. Are you good with this? Can I erase? Yeah? Take that as a yes. So I'm going to go to here. Get rid of all this stuff. And change colors to yellow. Okay. Before I take the antiderivative of this, I'm going to come over here and I'm going to do a little sidebar. And I'm going to ask myself a simple question. If x is equal to 4, then what is u equal to? If x is equal to 0, what's u equal to? What are the answers? 9 and 1. We're with you, Liam. It's okay. It's a long day. That creates new limits of integration. So now I come over here, and this becomes a 9, and this becomes a 1. Okay? I can put those in there because that 9 and 1 are based on the u values, which is what I'm working with now. Okay, take the antiderivative. 1/2 times, we did this already, 2/3 u to the 3/2, and I'm going to evaluate from 9 to 1. Which would actually mean I've got 1/3 times u to the 3/2 evaluated from 9 to 1. 27 minus 1, all of that times 1/3, that is 26 thirds. Same answer. Math. I would argue that the original problem I did is easier because I don't have to do that sidebar to figure out what my new limits of integration are. However, occasionally, and occasionally means like maybe 1 or 2 multiple choice questions on the AP test, they will force you to understand that method. So I would be doing you a disservice if I didn't show you that method in orange. Which one should you use? I don't care. I personally like the first one better. I don't want to bother changing limits of integration. I just solve the problem, stick x back in there, and then simplify the equation. One thing I will mention is a lot of you on the quiz got very sloppy with your notation. So notice, when I start, I did my u substitution. I've got that first line in purple with an integral symbol. Then I cleaned it up a little bit, but I haven't taken an antiderivative yet. So I still have an integral symbol there. Once I take the antiderivative, that integral symbol has got to go away. So now I'm working without an integral symbol, and I use that vertical segment to show that I'm going to plug in for 9 and 1. And of course, since it's a definite integral, I'm going to get an exact answer. Amanda.
If they wanted to use like the limits of integration, like will they just say that in the problem?
They'll force it on you in such a way that you'll quickly realize that that's what they're making you do. I'll see if I can find an example for later. But there's no doubt you can't avoid it, whether you want to or not. Anything else? Beautiful. We're all done. So, I'll unlock the day 48. I think it's already unlocked. But while you're working, I'll come around and pass back your quizzes. Once everybody has your quiz, I will go over it with you because I think there's some important points that everybody needs to see.